A $28,000 recon drone just outplayed a $120 million Russian radar. Not by fighting it, by ignoring it. You clicked for the bridge strike, you're in the right place. Tonight, we break down the ISR cycle beneath the Dnipro bridge, decoys up top, silent 32 below, and an AI bunker that waited for one perfect load alignment. We'll show how structural oscillation mapping and weight distribution turned a convoy into a trigger, and why the Nebo-M never saw the real threat. Stay, and you'll learn exactly how sensing, not missiles, decided the moment the bridge died. Before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. It costs you nothing, but it makes a huge difference to us. So, did you click the subscribe button? Great! Thank you so much. Now, back to the video. If a $120 million radar stares at the sky, what happens when the real threat hugs steel and silence under the deck? The plan ran on two layers. Above the Dnipro bridge, throwaway emitters and a Mavic 3 kept the air busy, enough signal, enough motion, to pull eyes upward. Under the span, a low-slung platform nicknamed Silent 32 hugged the girders, cutting wake in the dead zone where engines echo and traffic noise blends. You get a puppet show in the clouds, and a thief in the crawlspace. One is cheap and loud. The other is patient. Meanwhile, Russian counters lit up at the top of their scope. Short-range defenses chased dots and glints. Jammers pushed wideband glare. The bridge kept its daily cadence, diesel, brakes, axle thumps. To a watchstander, the net felt full. But the hook hung under the deck, out of the beam, out of the habit path of the gunners. Passive sensing under a bridge works because steel talks when you load it. Every truck step changes the tune. Accelerometers catch vertical bounce, contact mics drink in harmonic overtones from welds and rivets, a magnetometer reads tiny field shifts as stressed metal reorients. None of this radiates. It only listens, then matches what it hears to known patterns of span oscillation, joint slip, and deck rumble. Nebo-M is a heavy hitter when you give it what it wants, something big, high, and reflective. It reaches far. It warns early. But substructure micromotions don't show up on a long-range air search scope, and small, non-emitting platforms tucked into steel shadow don't throw enough radar skin to matter. That's the blind side, mighty against birds in the blue, indifferent to ants in the beams. Up top, the decoys did more than blink. They transmitted timed pings to seed false tracks, through off-angle reflections with cheap corner reflectors, and used LED strobes tuned to confuse autotrack optics. A few balloons with thermal pads made warm spots drift in the right wind. The effect was a fake sky with depth, targets that split, merge, and lure missiles into chasing noise. Electronic warfare shifted bandwidth to tame that mess. Surface-to-air crews watched streaks and flares. The underside stayed quiet. While that circus played, the bridge became a scale. Weight distribution mapping is simple physics turned into a signature. As each axle hit the span, the deck bowed and snapped back, and the waveform told a story: axle count, spacing, tire type, even speed drift on the approach. Ammo trucks carry a stiff, tall mass. Their axles load in a way that leaves a fatter low-frequency tail and a shorter rebound. Over a few cycles, the system built a fingerprint. When that print rolled in again, flags popped. The ISR loop stayed strict. First, detect without speaking, let the metal sing to you. Then, identify by oscillation signature, separate fuelers from flatbeds, empty from heavy. Next, track the cadence, how long between loads, which lane carries weight, where the node lines sit when the convoy hits mid-span. Finally, target by alignment, line the weak mode, the heaviest axle, and the least redundant section. No heroics. Just timing. So the $28,000 bird didn't outduel a radar. It sidestepped it. It harvested physics where the beam had no reach and the operators had no habit. The bridge told on itself, and the convoy told on its cargo. Now that the heartbeat is mapped and the weak chord is marked, the only variable left is the clock, when the span takes the right kind of weight at the wrong point in its cycle, and how little force it takes to nudge that failure into motion. The strike clock didn't start with a trigger man. It started when an algorithm saw a pattern in steel. Inside the bunker, the feed looked plain. A vibration stream from Silent 32. Video from the Mavic 3. Low-power relays piping in traffic rhythm and lane use. The system fused it, frame by frame, into a living model of the span, flex lines breathing, nodes drifting, cadence marking out the convoy's pulse. You could freeze it and still feel motion. Load in. Load out. Repeat. Human eyes saw trucks and shadows on weathered deck plates. The model didn't care about paint or flags. It read phase lag between girders, it tracked node stress as weight walked toward midspan, and it plotted a loop, the same rhythm rolling back every few minutes with only small errors. That loop was the tell. The convoy ran on a clock. The steel did too. Bridges carry hidden maps called modes. Midspan wants to bow, near the pier wants to twist. Those become nodes, lines where motion swaps direction. Hit the midspan in its flex peak and the whole field amplifies. Hit near a pier when torsion opens and the crack rides the flange. When weight and blast line up with that phase, the bridge stops acting like a solid beam and starts behaving like a tuning fork. Energy stacks. Small pushes land big. Resonance is the lever. Each span owns a set of natural beats. Traffic rarely matches them cleanly, but a loaded rhythm nudges closer. Add a short, sharp shock when the waveform crests, and stress multiplies at joints and bolts, not evenly, but in spikes the eye can't see. That's how a light charge can tear a heavy frame, by sending force where the metal already leans. Convoy makeup matters. An ammunition hauler rides stiff. Axle gaps hold steady, the rebound is blunt, and the low-frequency tail lingers as tires climb off the node and the box keeps swaying. Fuelers slosh. Flatbeds breathe. The algorithm sorts those by their weight print, then flags spacing that forces two heavy axles onto the same mode line. Speed is a dial. Too fast and the load skips the beat. Just right and it sits on it. So the AI set a gate. No fire unless three things align: enough weight on the node, the convoy's position at the chosen panel, and the oscillation phase in the optimal slice. The window is seconds wide. Miss it and you waste energy in dead steel. Hit it and the structure takes the blow for you. The charge stays small because the physics do the lift. Jamming rolled in waves, but the network stayed dark. No outbound pings. Navigation ran offline, using stored profiles of the span and passive triangulation between known deck echoes, tower edges, and the hum of traffic. The fire chain came pre-cleared and time-locked, waiting on sense truth, not a radio call. If the phase drifted, it held. If the load thinned, it held. Patience is a weapon. Up top, decoys still sang. Electronic warfare still soaked bandwidth. The radar still stared up. The model didn't hurry. It watched the convoy keep its promise. The same spacing. The same pause at the approach. The same weight leading the string onto midspan as the nodal wave rose. The target defeated itself by being on time. Then the screen went green. The AI had marked the weak section hours back. It mapped weight without a whisper. It waited for the ammunition truck to sit on the crest and for the steel to bend into phase. The blast met the bow. Physics took over. With timing now the weapon and sensing the guide, the fight widened beyond one bridge. The takeaway stays sharp: win the intelligence race and the ground you stand on decides for you, not the missile in your hand. Superiority shifted. Not to brighter screens, but to quiet sensors that never spoke. Physics-informed ISR turned a billion-dollar contest into a timing problem you could solve with patience and a small charge. You watched how the bridge's own motion chose the moment. That's the new edge: data, not noise; rhythm, not reach. If you want deeper breakdowns of how ISR wins battles before the first shot, subscribe and comment what system you want decoded next. Comment your choice below. Subscribe and join a community that seeks to understand the realities of modern conflict. The sky was noisy. The steel told the truth. Learn to read the bridge, and you control the fight.
5 helicopters gone. $1 billion shield staring at ghosts. You clicked for the Novokakhovka strike. This is where Ukraine made the S-400 fire at phantoms while the real killers skimmed the dirt. We'll break down the 90-mile, ground-hugging run, how MiG-29s and Su-27s carried GBU-39s beneath the radar horizon, and the EW timing that turned Panzer and SA-15 into decoy chasers. By the end, you'll see how a $100 million Ghost Squadron opened the corridor, and why Russia's radar net became a liability in its own backyard. Before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. It costs you nothing, but it makes a huge difference to us. So, did you click the subscribe button? Great! Thank you so much. Now, back to the video. How do you make $1 billion shield waste missiles on air that isn't there? You start by feeding it reflections it expects to trust. Radar sees echoes, not intent. So you teach the net to chase the wrong story. Ukraine needed a narrow lane through a belt of short and long-range systems to reach a logistics node near Novokakhovka without burning scarce jets. The risk was simple: show a wingtip at the wrong height and you light up every scope from the river to the coast. So the plan began with electrons, not engines. The S-400 watches far and high, a wide stare that punishes anything proud of altitude. Panzer fills the gaps down low with guns and missiles tied to fast trackers. Tor, call it SA-15, sits near the target and cleans up what sneaks close. On paper, coverage overlaps, reaction chains are tight, and nothing gets a free pass. The break came from a deception stack that played to habit. EW teams built ghost tracks with the right rhythm, speed bands that looked like loaded jets, small altitude steps to mimic terrain bounce, heading drifts that suggested a formation nudging to time on target. They didn't just throw noise. They mapped their emissions to what Russian crews anticipated before a strike, the cadence that tells an operator, this one is real. Here's the physics edge. Long-range search radars see far but only above a curve. The Earth hides anything hugging the dirt. So you split the picture. Decoys threaten from above the bend and pull attention upward. The real route stays below the line, where tall sensors lose authority and short-range systems get saturated by clutter. Operators don't shoot at magic. They shoot at motion that makes sense. Training drills kinematic plausibility into muscle memory, contacts that climb at believable rates, hold spacing like a flight lead would, and cross-reference on multiple scopes earn a full engagement cycle. The ghosts gave them that. Enough to start the checklist, cue illuminators, and allocate interceptors. You add bait with hardware. Small UAVs and expendable jammers light the spectrum in narrow bands, just loud enough to look like pods on fast movers. Their radar cross-sections stay modest, but their RF energy seeds trackers with returns. Panzer, built to pivot fast, shifts to optics when search gets noisy, and optics demand a sector. Point the glass the wrong way, and you hand the sky behind it to the threat you don't see. While crews work those tracks, command posts commit. You hear the clack of reload drawers, the calls for ready rounds, the shuffle of launchers into better arcs. But the quadrant is wrong. Interceptors sprint toward phantoms. Batteries cycle through precious minutes where their tubes aren't aimed at the actual approach. Windows open and close fast in this game. That's enough. The Ghost Squadron isn't a fleet. It's timing laid over signal craft. It burns decision time, not fuel. And it forces a layered net to act like a single, distracted eye. When a defense fights where it was told to look, it leaves seams elsewhere. A sensor net can be a steel door or a revolving one. Today it spun. The sights were up and outward, counting inbound that never arrived. That was the cue. Treetops became cover. Ground speed became armor. The real run began, and every second of confusion bought by the ghosts mattered as 90 miles of dirt-hugging flight came alive. If the radar owns the sky, you don't fly in the sky. You turn the ground into cover. Valleys become armor. Ridges become walls. The route is a thread, and the jet is a needle pulled low and fast. 2 platforms carry the run, MiG-29s and Su-27s. They need a corridor about 90 miles long to a depot cluster near the river. Tall sensors stare for high flyers, so the flight plan drops to where the Earth breaks the line of sight. It's not stealth. It's geometry. Low altitude trades safety from big radars for danger from everything else. Reaction time shrinks. Fuel burn climbs. Buffers vanish. A single pop-up from a Panzer optic, a flare of a manpad seeker, and the run can end. So the stick stays steady, the throttle smooth, the route pre-briefed to the meter. Flight geometry is the trick. Riverbanks act like berms. A cut in the terrain bends the radar line upward. The jet rides that seam, nose level, wings twitching to hold a contour that keeps metal under the curve. The pilot treats a ridgeline like a shield and a bend like a blind corner. Every turn is mapped to mask, crosswind, and time on target. They carry small, smart steel. GBU, 39 class weapons and JDAM type kits add standoff with tight guidance, so the bombs don't need to be huge. A small warhead on the right point is cleaner than a big blast on the wrong one. A depot isn't one target. It's a web, pipes, tanks, pallets, forklifts, sheds, and rows of fueled vehicles. The aim is chain reaction. Hit a fuel truck parked by shell stacks. Heat climbs. Cases cook off in a wave. You don't blow the depot with one bomb, you start a fire that eats the rest. That's math the pilot can use when weight is limited and every pound costs range. The mission clock is tight. The ghost wave draws eyes up and pulls missiles outward. 30 to 90 seconds later, shadows date the ground as the real packages cross the last hill. The lead gets coordinates. A laser spot or a preloaded set of GPS points cues release. The jets don't linger. They don't circle. They push once, drop clean, and break for cover. Impact lands like a sentence. A shed peels at the seams. A fuel trailer vents, then torches. Flames ride the wind into the rafters. Secondary pops run along the stacks. By the time air defenders swing sensors back down, they're tracking heat plumes, not metal. SA-15 swivels show motion, but the launch window died 30 seconds ago. The aircraft are already pushing out at treetop height, masked again by the same bends that hid the approach. In the haze and shock, another layer hits. Fragments scythe across the flight line. FPV drones slip in over the perimeter and find soft targets, rotor hubs, open intakes, exposed wiring. 5 helicopters on the pad turn from assets to losses in minutes, not because the plan hunted them first, but because chaos made them defenseless and close to the blast. The depot's eyes go dark. The bridge links choke. Trucks stop mid-roll, drivers bail, radios spit static and half-words. You can hear the scramble as batteries try to reset the grid, S-400s rewarm, Panzers shift sights, crews call for fresh tracks, a command node near Enerhodar fights to push orders through a jammed net. But the trail the jets used is gone. The corridor closed as soon as they passed. That's the cruel part of timing in a layered fight. by the time defenders know where the blow came from, the knife is already sheathed and moving home. Electrons lie. Terrain hides. That's how a premier air defense ends up burning missiles at air and leaving a real corridor open. Deception, masking, precision, 3 levers that force waste, cause delay, and carve the window for a clean hit. You want deeper breakdowns of the tactics that actually shift battles, EW, terrain, timing, subscribe. Comment the next system or munition you want decoded. Comment your choice below. The gap between what a radar promises and what the ground delivers is where wars pivot. We study that gap here. The next target set is yours to pick, and we'll pull it apart line by line.